Algebra 1 skills number 29, factoring x squared plus bx plus c. Okay, so we'll see what this is all about. When you factor something, you're going to break it down to the simplest numbers or expressions that multiply back together to give you that something. Okay, so it seems kind of a mouthful there, but what we're talking about is, for a simple example, if you want to factor the number 15, you'd break it into 3 times 5. As 3 and 5 are the simplest numbers that multiply together to give you 15, for example. Now, we're not going to be factoring numbers or doing factor trees. We're going to instead factor something like this, an expression where b and c are going to be numbers. Okay, so you're not going to see b and c there. And when we factor it, and we'll explain why when we see an example, we're going to factor it into something that looks like this. And it's not going to quite look like this, as you're not going to have both plus and minus. You're going to have only one of the two. And these two numbers need to add to b, but at the same time multiply to c. And again, when we see an example, we'll talk about why that is. All right, so let's look at an example there to clarify that. So same look, again, b and c are numbers, 9 and 20. So what we want to do is our answer is going to look like this. Okay, we're going to fill this with both a sign, either plus or minus, and a number. And those two numbers must multiply to 9, add to 9 and multiply to 20. So you're adding to the middle and multiplying to the end. Okay, so to do that, what a lot of people do is make a table. You can do it on your calculator. You can do it on Desmos. You can do it in some different places. But here we've listed all, or at least the first several counting numbers and what they multiply to make 20. So 1 times 20 is 20, 2 times 10 is 20, 3 times this decimal is 20, so you're not going to consider that row. 4 times 5 is 20, and here's 5 times 4. Now, once you start repeating yourself, that's all the possibilities. Okay, so you start with 1 and just go down and make this table. So which of those, we know all these rows, and I don't count the decimal, but we know all these rows multiply to 20. Which one adds to 9? Well, of course, the 5 and the 4. Now, a couple issues here. I'm going to go ahead and present the answer. It's 5 times 4. 5 times 4 is 20. 5 plus 4 is 9. And you're generally not going to write this as a separate step. You're going to write it and then fill it in. A couple bits of advice for you. I would recommend writing the bigger number first. You don't have to. You could say x plus 4 times x plus 5. That's perfectly fine. But one little rule here, the bigger number will always match this sign right here. Okay, so it's nice to know. The bigger number, 5 is bigger than 4 before you consider signs. It's got to match this positive, okay? Now, these two don't necessarily match. They do here, but this one will. Okay, now you can always check yourself. 5 times 4 is 20. 5 plus 4 is 9. So this is the correct combination. And sometimes you have to consider signs. Okay, so let's look at 3 more examples. So example 2, we're not going to color code anymore, but x squared plus 4x minus 12. Again, you're trying to multiply to negative 12, and at the same time, you're supposed to add to 4 here. So here's a list of all the things that multiply to 12. Again, we've repeated this row, 3 and 4. You don't have to write that one twice. Okay, so which ones of those add to 4? Well, you might think, well, none of them do. 1 plus 12 is not 4, 2 plus 6 is not, 3 plus 4 is not. But since we have a negative, then you may want to think subtract. Okay, so 6 minus 2 is 4. So here's the answer. And again, 6 is bigger than 2 before you consider signs. We know 6 must match the first sign. Okay, now 2 may or may not. For the second time, it does, just coincidentally. But you can always check yourself. Play around your signs and check yourself. Does 6 times negative 2 make negative 12? Yes, it does. Does 6 plus negative 2 make positive 4? Yes, it does. So you have the right combinations. Okay, so let's get a couple more examples. Example 3, this time we're not even going to show the table. 72 has a lot of factors. So you would want to make yourself a chart, or you may not need to. You may just think to yourself, start with 1. If you're not sure what they are, go to 2, 3, and so forth. What are factors of 72 that add to negative 18? Well, they just happen to be 12 and 6. Okay, again, it might take a minute to find those. Again, we put the bigger number first. 12 is larger than 6 before you consider signs. And again, it matches that. And you don't have to put the 12 first. I do want to repeat that, but it helps. Okay, and this time, notice these do not match. Negative 12 times negative 6 is positive 72. Negative 12 plus negative 6 is negative 18. So you're in good shape here. Fourth and final example, they will occasionally throw in 2 variables. And this looks maybe more intimidating because you have a y. But generally, as long as it's squared on both ends and you got one of each in the middle, you'll do the same thing here. You just have to tack a y in your answer. Okay, so we're looking for the same thing here. And factors of negative 54 that add to negative 3 are negative 9 and positive 6. Let's check it. Negative 9 times 6 is negative 54. Negative 9 plus 6 is negative 3, so it checks out. And notice we need these y's here to make that y squared. And if you were to multiply that out, you're going to get this here. So let's take a quick moment to explain why is it that you're looking for two numbers that multiply to the outside and add to the middle. Well, if you were to distribute this out or use the FOIL method, as some people call it, that last term is going to be this times this, negative 9 times 6. So whatever numbers are in these positions are going to multiply together to make this. Now, also, if you do the FOIL or the distributive property, you're going to end up with like terms when you do x times the 6y and negative 9 y times x. So you end up adding those. So that's why we add to the middle and multiply to the end.